Hello. In this video, I talk about pulse coded modulation, which is also abbreviated as PCM, which is a very widely used standard in digital communication. It uses all the processes which we learned before. This uses the previous concepts we have learned like sampling, quantization, encoding, etc. etc. So let's have an overall picture of all these. First, we have a source of continuous time message signal which is passed through a low pass filter. So what is the purpose of passing through a low pass filter? We need to have a band limited signal. So we pass through a low pass filter, then we sample it, we make it in discrete in time, and then these discrete in time signals, they are being quantized in order to make it digital in nature. In order to transmit it through a channel, we need to convert it to a particular voltage. So we have an encoder here. We encode these quantization levels to appropriate binary values, and these binary values, they are converted to voltage and being transmitted. The coming slide will explain the different types of encoding, different types of waveforms related to encoding. However, this encoded data, the digital data, is being transmitted through a channel, and this channel, it will consist of a transmission line. Of course, there will be some shaping for the PCM data, which is beyond the scope of this video right now. However, interested readers can refer to textbook written by Simon Hakin regarding digital communication. There are a series of regenerative repeaters. What a regenerative repeater does is, it receives the signal, it reshapes the signal, it equalizes for the time and amplitude distortion, and it makes that signal which was added with noise, the signal once it gets into the channel becomes added with noise. It makes that signal, it reshapes that signal, it makes the signal clean, and this clean pulse is again transmitted until it reaches the next regenerative repeater placed after a particular distance, and this channel output is fed to the receiver. The receiver has a regenerative circuit similar to regenerative repeater. This encoded signal is being decoded. There is a reconstruction filter which was explained while we were discussing sampling. The reconstruction happens and then it reaches the destination. So this is a block diagram of pulse coded modulation, how pulse coded modulation happens. Now let us see how these quantization levels are encoded in PCM data sequence. So the coding of representation levels, here the quantization levels are represented from 0 to 15. So naturally we need 4 places of binary digits, 4 places of binary data, 4-bit data for each symbol. So 0000 to 1111 is used to encode these quantization levels from 0 to 15. Now after encoding, we need to transmit this through the channel. So we need to convert this to some voltage. So there are a number of waveforms associated with encoding of these binary digits to a particular voltage, and these voltages can be modulated in different ways. For 0 you can give a negative value of voltage, for 1 you can give a positive value of voltage. There are a number of methods. Let us discuss a few. Here UNRZ, the first waveform, it stands for unipolar non-return to 0. Unipolar means it has only one pole. It is either positive or it is fully negative. It is called unipolar because of that. it is non-return to 0. It doesn't return to 0 after a bit duration. Alright, after a bit duration it changes to the next binary level. Here the binary level should be 1 0 1 1 0 1 0 0 1. Next is a polar non-return to 0. So polar means there are two poles, either it is a plus voltage or a minus voltage. So here according to the binary data 0 1 1 0 1 0 0 1, we have a positive voltage, we have a negative voltage, and this is called a polar non-return to 0. Then we have unipolar return to 0. So it has only one pole, but it returns to 0 after a fraction of bit duration, and it changes its value only after that bit duration. Alright, so it is unipolar return to 0. Next is bipolar return to 0, which has two poles, plus or minus, but again it is a return to 0 type of signaling. So after a fraction of bit duration it comes back to 0, it returns to 0 and then changes its amplitude only for the next bit duration. That's all for this video. Thank you so much.